In this module, you will see how the knowledge of sets can be applied to solve practical problems. We have already seen the operations performed on sets, such as intersection, union, and difference of two sets. Let us verify some results based on these relations. To begin with, we will verify the relation n of A union B is equal to n of A plus n of B, provided A and B are disjoint sets. Let's verify the relation using an example. Let's consider two sets A and B. These sets are disjoint sets since there are no elements in common. The number of elements in set A is 4. The number of elements in set B is 5. The union of the sets consists of the elements as shown. The number of elements in the set A union B is 9. Now, we can see that the number of elements in set A union B is equal to the sum of the number of elements in sets A and B. Therefore, the relation is verified. Next, we will verify another relation shown here. The relation holds provided sets A and B are finite sets. Let's verify the relation with the help of a Venn diagram. From the figure, we can observe that the sets A minus B, A intersection B, and B minus A are disjoint sets. Also, the union of these three sets results in the set A union B. We will use this fact to obtain our original relation. It follows that the number of elements of set A union B is equal to the sum of the number of elements of each set taken independently. We will add and subtract n of A intersection B as shown. From the figure, we can observe that the sum of elements in the sets A minus B and A intersection B is equal to the number of elements in set A. Similarly, the sum of elements of the sets B minus A and A intersection B is equal to the number of elements in set B. Therefore, we get the following equation. Hence, the relation is verified. We will now verify this relation. Momentarily, let's denote B union C with the letter D. This can be written as shown. Now, we will replace the letter D with B union C. The third term can be written in the form shown using distributive law. Therefore, we can write the expression as shown. Now, we expand the second term on the right-hand side. The third term can be expanded as shown. Hence, the relation is verified. We will see some practical situations where we can use these relations. In a village, 150 people subscribe to In a village, 150 people subscribe to Indian language dailies, 75 to English dailies, and 45 to language as well as English dailies. Find the number of people who subscribe English or language dailies. In the set theory, the word "and" suggests an intersection and the word "or" suggests a union of sets. Let V be the set of people who subscribe to language dailies, and E be the set of people who subscribe to English dailies. Let V intersection E be the set of people who subscribe to English and language dailies. We have to find the number of people who subscribe to either English or language dailies. The number of elements in each set is as shown. We will use this relation to find the number of people who subscribe either to English or language dailies. Substituting the values, we get the number of people who subscribe either to English or language dailies as 180. Let's see another problem. On a particular day, 300 students visit cafeteria. 110 students go there for lunch. 225 students have snacks and 50 students have both lunch and snacks. Find out the number of students who had lunch but not snacks, snacks but not lunch, either lunch or snacks. Let U be the universal set of all the students who attended the cafeteria. The number of students in this set is 300. Let A be the set of students who attended the cafeteria for lunch. The number of students of this set is 110. Let B be the set of students who attended the cafeteria for snacks. The number of students of set B is 225. The number of students who had lunch and snacks is given by A intersection B. The number of students who belong to this set is 50. Now, we will find the number of students who had lunch but not snacks. From the Venn diagram, this is given by the set A minus B. The number of elements of this set is given by the number of elements of set A minus the number of elements of set A intersection B. Using the values, we get the number of students who visited the cafeteria only for lunch as 60. Next, we will find the number of students who had snacks but not lunch. This is shown by the shaded region in the Venn diagram. The number of elements of this set is given by the relation shown. Using the values, we find that 175 students had snacks but not lunch in the cafeteria. Now, we will find the number of students who had either lunch or snacks. This is given by set A union B. This is given by the relation shown. Using the values, we get the number of students who had either lunch or snacks as 285.